Very good morning, students. In chemical kinetics, after the exhaustive discussions of average rate of reaction, factors affecting the rate of reaction, now we take a very important topic for today's discussion is how to calculate the unit of the rate constant. Dear students, let us assume let a reaction Na gives the product according to which law? Rate law. You have done in the 11th class, there we have discussed about the law of mass action. The rate of reaction is directly proportional to the product of concentration of the reacting species raised to their power equal to their stoichiometric coefficient. Dear students, so this time according to this law, rate is directly proportional to a ki power n. Rate is equal to proportionality change into k, rate constant, and then a ki power n. There k is equal to rate upon a ki power n. Anybody tell me what is the unit of the rate? The rate at which the reaction takes place. That the change in concentration per unit time is the rate of reaction. So here you put here mole liter minus 1 second inverse is the unit of the rate of reaction, and then it is the concentration. So there you take mole liter minus 1 and the power n. So finally you can take it mole liter minus 1 and then you can take it 1 into mole liter minus 1 minus 1 into second inverse. Bases same, powers are added. So k equal to mole liter minus 1 minus 1 and 1 minus n into second inverse. This is the very useful formula to calculate the unit of the rate constant. There you can ask me, my dear students, what is n? N is called actually order of reaction. N is here order of reaction. So to explain the order of the reaction, let XA plus YB gives the product. So according to rate law, rate is equal to, say here, A ki power X into B ki power, what is that? Y. Rate is equal to K into some of the powers of the concentration of the reactants is called the order of the reaction. Some of the powers of the concentration of the reactants or reacting species used in the rate law expression is known as order of reaction. So what is for this reaction, what is the order of reaction? X plus Y is the order of reaction. Right? So if n is the order of reaction, then n can be 0 order reaction, n can be 1 first order reaction, n can be 2 second order reaction, n can be 3/2 fractional order of reaction. So any type of questions you can solve by taking this formula. Now you take n is equal to, what is that? 1. If n is equal to 1, it is the first order reaction. What is the unit? K is equal to rate. K is equal to, what is that formula? Mole. This formula you can apply here. Mole liter minus 1. Mole liter minus 1. 1 minus 1 into second inverse. So K is equal to mole liter minus 1 ki power 0 into second inverse. You know it very well. Anything raised to the power 0 is 1. So finally the unit of rate constant for first order reaction is, answer is only second inverse. If I take the second order reaction, so n is equal to 2, so rate unit is equal to mole liter minus 1 minus 2 second inverse. So that is why mole liter minus 1 minus 1 second inverse. So mole minus 1 liter into second inverse. The way you can calculate, you take the n is equal to 3/2. Anybody tell me if it is the fractional order reaction 3/2, the way you can have K is equal to mole liter minus 1 minus 3 by 2 into second inverse. So mole liter minus 1 minus 1 by 2 into second inverse. So mole minus 1 by 2 liter 1 by 2 into second inverse. You can have zero order, first order, second order. Higher order reactions are actually not possible because the collision is not effective and not symmetrical. So actually it can be zero, first or second, or even fractional order reaction. So this is all about the how to calculate the limit of rate constant. Then you can ask me what are the features of the rate constant. So see, features of rate constant. First is the more the value of the rate constant, I mean K, faster the rate of what? Reaction. Greater the value of temperature, greater the rate of reaction. Rate constant is independent upon molar concentration of what? Reactants. And then finally the rate constant depends upon it differs from reaction to reaction. If n is equal to 1, so unit is different from 0 order. If n is equal to 3 by 2, obviously it is different from the 0 and the first order. So it differs from reaction to what? Reaction. Then after that, these are the features of the rate constant. My dear students, to explain the chemical kinetics, you see it is highly conceptual and numerical oriented chapter. And there one thing, to explain the mechanism of the rate of reaction, two parameters are very, very important. One is molecularity and other is order of reaction. So let me make the difference between molecularity and what is there? This is the order of reaction. So molecularity is very simple. Total number of moles of the reactants used in the reaction to form the products is called molecularity. So what is there? For example, if I say XA plus YB, that gives the product. What is the molecularity? X mole of A and Y mole of B, so X plus Y, right? For example, you can say H2 plus I2, that gives, what is that? 2HI. What is the molecularity? 1 mole of H2 and 1 mole of I2, 1 plus 1, what is there? 2. So molecularity is like N2O4 here. So this is the N2 plus 2O2. Molecularity is 1. So total number of moles of the reactants, simply you can say molecularity. But order of reaction is different from molecularity. It may or may not be same. See here, order of reaction is sum of the powers of concentration of reacting species used in rate law expression is called as order of reaction. Let XA plus YB, that gives the product. According to rate law, rate is equal to K into A ki power X into B ki power Y. So what is the order of reaction? Sum of the powers of the concentration. So my dear students, what is that order of the reaction here? This is the X plus Y. If I say H2 plus I2, that gives 2HI. Anybody tell me What is the order of the reaction? So rate is equal to K into H2 की power 1 into I2 की power 1. So this is the order is equal to sum of the power. This is the 1 plus 1. It is what is that? Order of reaction. Whatever the exponent is given for the concentration, the way you can calculate the order of reaction. Some of the powers of the concentration of the reactants. Second point of difference, molecularity is actually theoretical concept. It is the apparent values, but it is the experimental part here. Now, next difference is the molecularity is never zero. Order of reaction may be zero. Molecularity is never in fraction. But my dear students, order may be zero, fractions, or even what number? This is the whole number. These are the differences between molecularity and order of reaction. Molecularity is the total number of moles of the reactants. Order is the sum of the powers of the concentration of the reacting species. Order of reaction, it is highly experimental. It is theoretical. It is never zero, it can be zero. It is never in fractional, it can be fractional. For elementary reaction, molecularity and order are same. But for complex reaction, molecularity is different from order of